Okay, so now we're going to discuss regression problems, but with different functional forms. Okay, so regression with other functional forms. Okay, so let's look at the first one, which is, say, the generalization. It's like from just linear functions. It's like to say nth degree polynomials. Okay. Okay, so I'm looking for y is equal to a0 plus a1x plus a2x squared all the way up to anx to the nth power. Okay, and as before, where the number of sort of data points m is greater than or equal to n plus 1. Okay, because again, we want to be in a situation where you have at least as many equations as unknowns. The number of unknowns you have in a polynomial degree n is n plus 1. Okay. All right, so your unknown vector z now is this vector of coefficients a0 all the way up to an. Right, and I want to write this equation, all m of them, okay, where I substitute xi, yi for the x and y's, okay, all m of them as a linear system of equations, az is equal to b. So you can check that this A matrix will look like the following: column of 1s, column of x's, columns of xi squared, x1 squared, xm squared, and you keep going to x1 to the nth power, xm to the nth power. All right, and then your b vector is just the right hand side, which is y1 to ym. Okay, so that's the equation you want to. That's the system of equations. It's like, and you want to minimize the error. It's like you have, in satisfying those equations, right? And you can check that as before. The normal equations for this is just given by A transpose A z is equal to A transpose B, right? And this is going to be an n plus 1 by n plus 1 system of equations. Okay, and you can, solving the normal equations gives you the solution in the least squares sense. Okay. Okay. All right. So let's look at some other functional forms. Say maybe least squares with exponentials. Okay, so let's say that I assume the following functional form. Y is equal to beta e to the alpha x. So what I'm going to do in order to convert this into a linear system of equations is to take the log on both sides, the natural log on both sides. So the natural log of y is equal to natural log of beta plus alpha x. Well, okay, plus the natural log of e to the alpha x, right, which is the natural log of beta plus alpha x. Okay, all right, so your unknowns are beta and alpha, okay, and So this has a linear form in the following sense, right? So now I'm going to have these terms here. So I'm going to write that equation as AZ is equal to B as before, right? But the unknowns are going to be natural log of beta and alpha. Okay, so Z is going to be natural log beta, and the second unknown is alpha. This A matrix is still going to be the column of 1s and x1 to xm, right? But the right-hand side is going to be the natural log of the data, of the y's. So B is going to be the natural log of y1 all the way up to the natural log of ym. Okay. So taking the natural log, it's like sort of converts this expression into some sort of linear least squares problem. Okay. So taking the natural log, turns the exponential relationship into a linear one, right? And then you can solve A transpose A, Z equals to A transpose B, which is the normal equations as before, and then beta is equal to E to the Z1, right? So that's the first component of this Z vector, and then alpha is Z2, right? So that's all you have to do. Okay, so that's one functional form involving an exponential. Let's look at another one. So let's say we now have that y is beta x to the alpha. Okay, and as before, I'm going to take log on both sides. So I have the natural log of y is equal to natural log of beta, right, plus alpha natural log of x. Okay, all right. So, now, again, I want to write this as a linear relationship. AC is equal to B, right? So Z is going to be natural log of beta, and then alpha, and A is going to be column of 1s, and then a column of natural logs of the xi's. And B is going to be the natural log of the y's. Okay, and again you solve the normal equations. A transpose AZ equals to A transpose B, right? And then Z1 is natural log of beta, so beta is the exponential of Z1, and then alpha is Z2. Okay, all right, so that's just a few ways of, or a few other functional forms. It's like which can be converted. It's like into linear relationships between some function of the data. Okay, and then from that, it's like you can do the regression. It's like using least squares, and in particular solving the normal equations in order to figure out what the regression coefficients are. Okay, so let me just stop here for now.